Today we're going to look at a book called The Technology Behind Everyday Appliances. So let's take a look at the table of contents first. So in our table of contents, we have the contents of the book broken down. There is what is technology, the technology behind everyday appliances, and then I noticed that the rest of the book is organized by some questions. So there's how does a screw work? What is a toilet's S-bend? What makes a light bulb light up? How does a zipper work? Why do you put water in an iron? How does a refrigerator keep things cold? Does a vacuum flask keep things hot or cold? How does a can opener work? What keeps nonstick frying pans from sticking? How does a television signal travel through the air? How do cell phones work? Why doesn't a microwave oven get hot? And how were liquid paper and Post-it notes invented? And then there's an index. And then at the bottom here, we've got a little note. And it says, look out for these features throughout the book. So we're going to look at for something called a word watch. And a word watch explains the meanings of words that are shown in bold. And then we've got a web watch. And the web watch provides websites, suggestions for further research. So we're going to skip and we're going to start on page 4 here. What is technology? And so right off the bat, as I'm noticing lots of text features, thinking back to our Making Meaning unit. I noticed that there are photographs here with captions. People use technology every day, such as when they're turning on computers. Technology is science put into action to help humans solve problems. We've got just little sidebars here of information. There's a word watch. So the word science is defined for us. We have words in bold. We have some of these subheadings: technology in people's life, new invention, most popular inventions. We have additional photographs and a couple of more sidebars, another word watch with the word devices and industrial. So let's see what they have to say. Technology is the use of science for practical purposes such as building bridges, inventing machines, and improving materials. Humans have been using technology since they built the first shelters and lit the first fires. Technology in people's lives. Technology is behind many things in people's everyday lives, from light bulbs to can openers. It has shaped the sports shoes people wear and helped them run faster. Cars, trains, airplanes, and space shuttles are all products of technology. Engineers use technology to design and construct materials and structures such as bridges, roads, and buildings. Technology can be seen in amazing built structures all around humans. Technology is responsible for how people communicate with each other. Information technology uses scientific knowledge to determine ways to spread information widely and quickly. Recently, this has involved the creation of the internet and email and file sharing technologies. In the future, technology may become even more a part of people's lives with the development of robots and artificial intelligence for use in businesses, in the home, and in science. At home, so this is the technology behind everyday appliances. At home, at school, and in offices, people are surrounded by devices and products that make life easier, more productive, and more entertaining. All of these everyday appliances have one thing in common. We cannot imagine how people lived without them. New inventions. Some everyday appliances, such as the screw and the steam iron, are the result of scientific discoveries and gradual changes in technology over hundreds of years. Others, such as Post-it notes, seem to spring up out of nowhere. Some appliances are invented because there's a need for them, such as can openers. Other appliances can help us do the same things, but in a new way, such as using a zipper to fasten our jeans instead of buttons. Most popular inventions. Of all the things that have been invented, humans seem to value everyday appliances the most. According to a website, the 10 most popular inventions are telephone, computer, television, automobile, the cotton gin, which was a machine that separates cotton after it's been picked, camera, steam engine, sewing machine, light bulb, and penicillin. So here's our first question. How in the world does a screw work? And I noticed before we get started in reading that, let's take a look at all of the text features. We have subheadings. So the screw, the history of a screwdriver, history of the screwdriver. Lots of graphics here, lots of photographs. with little captions, a picture of a screw. This looks like somebody demonstrating how a screw might work. We have a word watch here. We're going to look for force. Kind of sounds like a sciencey word. Device, fastener, friction, inclined plane, and lathe. And we've got some little sidebars of additional information. So let's find out, how does the screw work? One of the most common objects in homes, offices, schools, and other buildings is a tiny metal device that is normally hidden from view. Screws can be found just about everywhere, inside computers and cupboards, and tables and chairs, and on door frames and windowsills. A screw is usually used to join two materials together. When turned one way, a screw moves farther and farther into a material. The screw cannot be pulled out because of friction between the screw and the material. If turned in the opposite direction, however, the screw will move farther and farther out of the material. History of the screw. The screw shape was first used as a device for raising water out of a river or well. This technique was used in the Middle East from about 700 BC, and it was described by the Greek scientist Archimedes in about 250 BC. The device became known as Archimedes' screw. It was not until the 1400s in Europe that the screw began to be used as a fastener. Fastening screws were handmade until the late 1700s when British instrument maker Jessie Ramsden invented a lathe for making screws. The screws had a single groove across the top. A screwdriver. A screwdriver is a tool for inserting, securing, and removing screws. It has a metal shaft, at the end of which is a tip that fits into the groove or grooves on the head of a screw. Screwdrivers that have a single edge are for screws with a single groove. Other screwdrivers have tips with multiple edges or pattern imprints to fit particular types of screws. The handle of a screwdriver is designed to fit neatly in a person's hand. History of the screwdriver. The screwdriver was invented in Europe in the 1700s, probably in France. It had several design changes throughout the 1800s, but then remained fairly unchanged for more than 100 years. In the 1900s, the Robertson and Phillips screws and screwdrivers were designed. And then we're also going to look at light bulbs and zippers. All right, so what makes a light bulb light up? I see the title up here at the top of the page. It's a question. We've got similar text features. We've got sidebars. We've got little graphs and pictures. We have our word watch again, electrons, atoms, combustion, and inert gas. We're getting a little fancier with our science terms. We have a photograph here of Thomas Edison. And then there's a web watch if we want to know more about light bulbs. All right, so what makes a light bulb light up? Light bulbs have been around since the 1800s, and the design of some has remained almost unchanged. With a simple flick of a switch, they light up a room. We all enjoy the technology of a light bulb. Incandescent light bulbs. Common pear-shaped light bulbs are incandescent light bulbs. These light bulbs are very inefficient. This is because 90% of the energy they give out is in the form of heat, and only 10% is in the form of light. How an incandescent light bulb works. When a light switch is turned on, electricity enters the bulb through the contacts at its base. The electricity then travels up the wire to the filament, which is right up here, and the electricity heats the filament to the point where it glows white. Fluorescent light bulbs. Fluorescent light bulbs are more efficient than incandescent light bulbs because they produce more light per unit of electricity. They do not lose so much energy in the form of heat. How a fluorescent light bulb works. When a fluorescent light bulb is connected to an electricity source, the electrodes emit particles called electrons. These electrons travel around the tubes, so see the tubes here, and collide with mercury atoms. When they collide, the electrons release a burst of ultraviolet light. Ultraviolet light cannot be seen by humans, but phosphor powder turns the ultraviolet light into visible light. And then, how does a zipper work? I know this question has been keeping you guys up late at night, hasn't it? And so we've got the same kind of text features. We've got some graphs, some photos, some sidebars, some web watches, and some words. The words are device, fastener, and force. All right, so how does a zipper work? Without zipper technology, people would have to fiddle with buttons to do up their jeans, boots, and jackets. The simple zipper is made up of a combination of wedges and hooks. How a wedge works. A wedge is an object with a slanted surface that is designed to move something apart or keep two things apart. When you apply a wedge to an object, the energy that you apply pushing the wedge in converts to a force that works at right angles to the wedge's movement. How a hook works. A hook is a curved piece of material that grabs onto and secures another material. It is a fastener. An everyday example of a hook is a curved device on the back of a door for hanging hats and coats. Hooks are often metal. How does a zipper work? The wedges and hook in a zipper work together to fasten and unfasten the zipper. The zipper's slide contains 3 wedges, and the zipper's teeth are made up of hooks and hollows. So when the slide is pulled up the zipper, the lower wedges in the slide push the hooks into the hollows, securing the teeth and fastening the zipper. And then when it's pulled down, the upper wedge detaches the hooks from the hollows and forces the teeth apart, opening the zipper. Absolutely fascinating, right? Cool. And the zipper was not invented until 1893, and it was invented by a man named Whitcomb Judson because he wanted to make it easier to close and open men's boots. But then a Swedish engineer in 1912 improved his design, and the zipper became a popular and practical device after 1912. The first large-scale use of zippers was by the Navy, and they ordered 10,000 zippers for flying suits in 1918. So, we've learned about zippers, we've read about how screws work, and we've learned a little bit about technology. And so today you're going to be invited to do some thinking about some other everyday appliances that you might wonder about. There's some other examples here in the book that we did not get to read, like the bend in the toilet. What else? Water in an iron. How does a refrigerator keep things cold? Can openers, cell phones, television signals, frying pans, all kinds of everyday items and how they work.